Welcome to the session of electromagnetic waves and transmission lines. In this session, we will be discussing the primary coordinate systems that are essential for understanding the electromagnetic field theory. There are many coordinate systems which are available in the mathematical literature, but mainly we focus on three coordinate systems for electromagnetic theory. They are the first one, Cartesian system, next cylindrical system, next spherical system. Well, you know, Cartesian system is the most basic and general form of coordinate system that we use. Unless otherwise mentioned, by default we stick to the Cartesian coordinate system. Next, coming to electromagnetic theory, we have study of electric fields, we have study of magnetic fields. The study of static electric fields is called electrostatics. The study of static magnetic fields is known as magnetostatics. Mostly in electrostatics, we go for the spherical coordinate system, whereas on the other hand, for magnetostatics, we go for cylindrical coordinate system. In simpler terms, I will just show you why it is so. If you have an electric charge, it is surrounded by its own field, we say electric field. That electric field cannot be visually seen with our eyes. So, that electric field of an electric charge is represented in the form of imaginary lines, and there is force along the lines. So, we say lines of force. This is due to electric charge. So, we say electric lines of force. So, electric lines of force will be all around the electric charge. Now, this is charge Q1. This is charge Q1. Now, to know the electric field intensity of this charge Q1, take a test charge Q2 somewhere here. Now, Q2 will experience a force due to Q1. Whether you keep Q2 here or here or here, you move Q2 all around Q1. Q2 will experience electric force due to Q1. Now, the crux of this discussion is electric charge and resulting electric field. Now, what is this geometry? Of course, this is a screen, so you find it as circle, but in real space, that is three-dimensional space, it is not circle, it is sphere. Circle means 2 dimension, sphere means 3-dimensional. Because it is a screen, you are seeing like a circle, but in real 3D space, it is sphere. This is center of the sphere, this is radius of the sphere. So, it is a spherical system. The most convenient form in this particular case is spherical coordinate system. And I told you that cylindrical system is used in magnetostatics. What is magnetostatics? Study of static magnetic fields. Now, you know very well that if there is a conductor, electric conductor, let us say this is a conductor, and current is flowing in it, let us say current is flowing, I will just show you here. There is a conductor in which current I is flowing. You know very well that a conductor carrying current is surrounded by magnetic field. Magnetic field is surrounding the current carrying conductor. If current is here, magnetic field is surrounding here. If current is here, magnetic field is surrounding here like this. If you join this, what do you get? You get a cylinder. So, this is a cylindrical coordinate system. Magnetic field due to the flow of current. The study of magnetic field comes under magnetostatics. Of course, static magnetic field I am saying, it is not time varying magnetic field. So, this cylindrical geometry is appropriate for magnetostatics. So, we go for that. That means, these are the coordinate systems. We do not say that this is best, this is worst. Appropriately, we have to choose the coordinate system. Next, coming to the coordinates. Every coordinate system will have its own coordinates and its own symbols. It is a 3-dimensional representation. Electromagnetic wave propagates in a 3D space, 3-dimensional system. So, we have 3 coordinates in each coordinate system. First, let us say the most familiar one, everyone knows, the basic and simple one, Cartesian system, which has 3 coordinates x, y and z. All the 3 coordinates indicates length only. Along x axis, length measured along x axis, along y axis, along z axis. All 3 coordinates indicate length. Next, cylindrical system. You find rho, phi and z. Here rho stands for radius of the cylinder, z stands for height of the cylinder, because it is cylindrical system. That cylinder will have radius, that cylinder will have height. Z stands for height of the cylinder and rho stands for radius of the cylinder. So, height you measure in meters, radius also in meters. So, two length coordinates. Next you have phi. Phi is angle measured in the azimuthal plane. So, phi is basically an angle. It is azimuthal angle. So, phi means angle measured in the azimuthal plane or horizontal plane. So, you have two coordinates for length, one coordinate for angle. Unlike in the Cartesian system, you have all three for lengths. Here two lengths and one angle. Next, coming to the third one, spherical coordinate system. R stands for radius of sphere, it is sphere, and theta stands for elevation angle, angle measured in the vertical plane. Phi stands for azimuthal angle, angle measured in the horizontal plane. So, you have these three coordinate systems with corresponding symbols. In Cartesian system, you have three coordinates for length. In cylindrical system, you have two coordinates for length, one coordinate for angle. In spherical coordinate system, you have R, which is length, one length coordinate, theta and phi, two angular coordinates. So, now we will see when you try to mathematically compute the integrals, that is, if you want to calculate these parameters, electric and magnetic parameters, the field parameters, often it is required to integrate over a sphere or a cylinder, depending on the scenario. So, when you compute the integrals, you take the limits of integration for this coordinates, then it is essential to know what are the limits of the integrals, or else I can say what are the limits of these coordinates. So, as you can see here, in Cartesian system x, y, z, all three coordinates have the same limits, that is, x can go from minus infinity to plus infinity, similarly y, similarly z. That means minus infinity means negative x axis up to infinity, plus infinity means it is also x axis but positive x axis up to infinity, similarly y and z. Next, coming to cylindrical coordinate system, you have rho. What is rho? Rho is the radius of the cylinder. At the center of the cylinder, we say radius is 0. Starting from 0, it can go up to infinity. Unlike x and y here, which starts from minus infinity, radius, it starts from center. This radius is measured from the center, whether it is cylinder or sphere or circle, anything. Radius is a mathematical geometrical parameter which is measured the distance from the center. So, if you are at the center, radius is 0. So, starting value of radius is 0. So, 0 here, it can go up to infinite. Infinite means it is a very, very big sphere, big size sphere. Next, you have phi, the angle measured in the azimuthal plane, horizontal axis. It goes from 0 to 2 pi. That means mathematically, when you integrate, you take the limits of rho going from 0 to infinity and phi going from 0 to 2 pi and z going from minus infinity to plus infinity. Like this you compute integrals. This is a mathematical way. So, for that you need to have these limits of integrals or limits of these coordinates. So, what is z here? Z is the height of the cylinder. It is cylindrical system, so it represents cylinder. Z is the height of the cylinder. The cylinder can go to the bottom, it can stretch to the bottom to minus z, which is minus infinity, and positive z axis, it can go up to plus infinity. So, we have limits minus z to minus infinity to plus infinity. Next, finally, you have the spherical coordinate system. R stands for radius of the sphere. Same, if you are at the center, radius will be 0. So, R starts from 0. It goes up to infinity because it is a very big sphere. If it is very big sphere, we say radius is infinity. So, limits of integral here, R goes from 0 to infinity because it is triple integral we use, because sphere, cylinder, these are 3-dimensional geometries. So, if you are integrating with respect to this geometry, then you have to have volume integral. Volume means 3 integrals, and theta goes from 0 to pi. 0 to pi. What is theta? Theta is the elevation angle. I will show you how it is measured in the next slide. So, theta goes from 0 to pi. Be very careful. Theta goes from 0 to pi. Pi goes from 0 to 2 pi. It is horizontal angle, horizontal plane angle or azimuthal angle phi. It goes from 0 to 2 pi. Because by definition theta means elevation angle, means if you have a plane, horizontal plane, if this is a plane, you have to measure the angle vertical in the vertical plane. You can come like you can measure like this or you can measure like this. But if you go beyond this, this plane, this horizontal plane, if you go beyond this, then this is called angle of depression. So, it is a violation of the term angle of elevation. Elevation means above this, angle of depression means below this. So, you cannot go below this. If you go below this, it is depression. So, confine above this axis. Above this means you can start here and go up to here. So, this is half, which is pi. You cannot go down. If you go down, it is depression. So, probe it here, because theta is elevation angle. So, it is pi. It goes from 0 to pi. Whereas this section is not applicable for azimuthal angle, because that is the angle measured in the horizontal plane. You can measure the horizontal angle all around the plane, 0 to 2 pi. You can start and end at the point where you have started. 0 to 2 pi you get here. So, this, while applying the integrals, you have to be very careful. When you take theta, upper limit will be phi only. If you take phi, the upper limit will be 2 pi. Next, I will show you the pictorial representation, whatever coordinate systems you have seen now, which are applicable for the study of electromagnetic theory. I will show you the diagrams, pictorial representation of these three coordinate systems. The first one, as you can see here, the primary, the simplest and the widely used and the general. By default, whenever we say coordinate systems, needless to say, anybody will write XYZ by default. So, that is why I say the basic, primary, the simplest and the default typical coordinate system that we use is Cartesian system consisting of x, y and z. Next, the second one, the cylindrical coordinate system. As you can see here, I am trying to map the cylinder on the existing Cartesian system, because all of us are familiar with the Cartesian system. So, I am not drawing the cylindrical system something different one. I am trying to map the cylindrical system on a Cartesian system, so that it becomes easier for you to understand. Now, this is a cylinder. Cylinder starts here, extends up to here. So, this is called height of the cylinder. So, that is why I labeled here Z is the height of the cylinder here, starting from here going up to here. Next, this is the cylinder and starting from center. If it is circle, you have center. If it is cylinder, you have axis. We say axis of cylinder. Of course, axis is along the center of the cylinder. If it is circle, we say center. Axis means for cylinder, axial. That is why we say this direction is called axial direction. Axis is at the center of the cylinder. So, from the center, this is the axis. From the center, measure any point on the surface of the cylinder. So, from this point to this point, this is called radius, or I have already shown here, from the center here to this point. You can take any point on the surface, that is called radius. I have labeled here as radius of the cylinder. Next, we have azimuthal angle, angle measured in the horizontal plane. So, how do you get that? Phi. What is phi? Now, whatever point you take on the surface of cylinder, take the projection of that point into the xy plane. This is y and this is x. So, this plane is called xy plane. Take the projection of this point on the xy plane. Let us say this point is P. Join point P with the center. So, this is the center. From the center, join this point P. So, this is a point. Now, the angle made by the line joining P and the center, angle made by this line with respect to the x axis, this angle is known as phi, azimuthal angle. XY means floor, horizontal plane. Next, coming to the spherical system, you can find here I have just drawn the dotted lines like this, which means you have to imagine. Dotted line means you have to imagine that it's imaginary thing, because this is a screen. You are looking on a screen. Screen is 2-dimensional thing. Sphere is 3-dimensional. I am trying to represent a 3D object on a 2D plane. So I have to use what is called as imaginary lines. So this dotted lines indicates the sphere. So the sphere can extend like this. I can close it. The sphere can be formed. I am not drawing the entire sphere. I have taken a portion, a section of the sphere like this in the form of dotted lines. Now what is radius? Radius of the cylinder. How do you get? Take any point on the surface of the sphere. This is the origin. What is radius? The distance measured from the center of the sphere to any point on the sphere. You can take any point. I have taken this point. You can take this point, or you can take this point. Any point on the surface of the sphere. So this distance is called the radius. I have labeled it as r here. Radius of the sphere. Next, what is theta here? Because in spherical system I have shown you. In spherical system you have two angles. One is elevation angle, one is azimuthal angle. Azimuthal angle just now we have seen. Azimuthal angle in cylindrical system we have seen. The same as spherical system. So you can see here, that point you have taken on the surface of sphere, join that point to the center. That line is called radial line, because that line is lying along the radius. So that is called radial line. The angle measured by this line with respect to z axis. Z axis is like this, vertical axis. What is theta? Angle measured in the vertical plane. That is why we are taking z. So what is the angle made by z axis with respect to this line joining center in any point on the sphere? The angle made by this line, radial line, with respect to z axis, this is called theta. This is called vertical plane, zy. This is called vertical plane. So this is called angle measured in the vertical plane, which is called theta. It goes from 0 to pi. Next you have phi. The definition of phi is same as in the cylindrical system. Just now I told you. For that, what you do? Take any point on the surface of sphere. Take the projection of that point in the horizontal plane. Means draw it, project it down. What is the horizontal plane? XY plane. This is horizontal plane. This is vertical plane. So take the projection of that point into the XY plane. Join that point to the center. The angle made by this line with respect to x axis is called azimuthal angle or horizontal angle. So these are the three different coordinate systems that we use in the study of electromagnetic field theory. The choice of the selection of the coordinate system depends on the scenario. In general, unless otherwise mentioned, if it is applicable, we go for by default Cartesian system. But if the situation demands, that means if the scenario in such a way that you have to choose a particular or appropriate coordinate system, there is no option. Either we have to go for cylindrical or spherical. But I have told you, spherical is used for electrostatic study, cylindrical is used for magnetostatic study, because I have shown you diagrammatically wise why it's so. So in the next session, we will continue with a new topic.